Okay, we have y equals 4 to the x, and we want to write 64 to the power x in terms of y. So 64 is 4 cubed, so 4 cubed to the power x, which is 4 to the 3x, which is y cubed. 4 to the power 2 minus 5x, well, I can write that as 4 to the power 2 divided by 4 to the power 5x, which is 16 over y to the power 5. And if I just want to write x, well, this one's to try and trick you a little bit. If I do log 4 of both sides, I get log 4y equals x. Okay, number 2, we have y equals e to the power 4x plus 1 divided by 3x minus 1 squared, and we want to get the gradient, so we're going to have to differentiate. So this is a quotient rule, so the formula is dy by dx is vu dash, take away uv dash, over v squared. So u is e 4x plus 1, v is 3x minus 1 squared, u dash is 4e 4x plus 1, and v dash is 6 3x minus 1. So put it into the formula. So those two terms together, so 4e 4x plus 1 times 3x minus 1 squared, take away these two. So 6e 4x plus 1 times 3x minus 1 all over v squared. So 3x minus 1 to the power 4, because when I square that times the power by 2. Now, I don't need to simplify it because I'm just going to sub in when x is 1. Now watch, again, I'm not using the calculator. If I sub in 1 to the first term, I get 3 minus 1 is 2, 2 squared is 4, 4 times 4 is 16, so it's 16 e to the power of 4 plus 1 is 5. Take away, so 1 into there, 3 take 1 is 2, times 12, 6 is 12, e to the power 5, divided by 3 take 1 is 2, to the power 4 is 16. And just simplify it, 16e5 to equal 12e5, it's 4e5, divided by 16, simplifies to just e5 over 4, or a quarter e to the power 5, if you prefer to write it like that. Okay, next one. We have f of x is 4x plus ex plus 2, and we want to get the inverse, so we call the inverse a different letter to y, so y equals f inverse of x. We apply f to both sides, and that means the f and inverse cancel out, so I get f of y equals x. So I sub in y into f, so 4 plus ey plus 2 equals x, and just rearrange. So take away 4 from both sides, do ln of both sides, and then take away 2 from both sides. So my inverse is minus 2 plus ln x minus 4. Okay, question 4. We have 3 tan squared x plus 2 sec x equals 5. We want all the solutions between 0 and 360. Well, this one's squared, so I can change this one. And tan is sec squared x minus 1 plus 2 sec x equals 5. Expands, so 3 sec squared x minus 3 plus 2 sec x equals 5. Take 5 from both sides, so 3 sec squared x. I'm going to put the 2 sec x minus 8 equals 0, which is a quadratic. So if y equals sec x, you get 3y squared plus 2y minus 8 equals 0, which if you solve it, you get y equals 4/3 or minus 2. So sec x equals 4/3 or minus 2. That's what y was. So flip them. So cos x equals 3/4 or minus a half, and then do cos -1 to get the first angle, and then take it away from 360 to get the second angle. So from the first one, you get 41.4 and 318.6. And from the second one, you get 120 and 240. And the last one, back to some pulleys. We've got two particles, mass 2 kilograms and m kilograms. And it says that m is less than 2, so that means this one's heavier. Attached by a lightly extensible string and hang over a smooth pulley. Given that the tension is 10, so the tension's 10, 10, 10, 10. Find what m is. Well, we know that we'd have 2g, or g there, 2g going down. Put the g there as well, mg going down. So this one will go down because 2 is heavier. This one will go up. So my two equations are 2g minus 10 equals 2a, and this one would be 10 minus mg equals ma. Remember, F equals ma. So I can solve the first one to get there. So 2g minus 10, so 2 times 9.8, take away 10, gives me 9.6 equals 2a. It's divided by 2, so a equals 4.8. I can sub into there, so 10 take away g is 9.8, so 10 take away 9.8 m equals 4.8 m. Add 9.8 m to both sides, so 10 equals 14.6 m, and divide both sides by 14.6. Gives me 0.6849, blah, blah, blah. And since we've used g's 9.8, I want two significant figures, so m equals 0.68.